In question number 2, this is also a graphing calculator question. The shaded region R is bounded by the graphs of the functions f and g. F of x is x squared minus 2x, g of x is x plus sine pi x. And we have the region is bounded above by the graph y equals g of x and below by y equals f of x. So in part A, they are asking us to find the area of region R. Show the setup for your calculations. So the area of this region, the area is equal to integral from the point of intersection from 0 to 3 on the x-axis, so from 0 to 3, okay, of above minus below. So the function above minus the function below dx. Okay, so the function above, as we can see here, it's g of x. So g of x minus f of x. And since we can use our graphing calculators, that's what we're going to do. So you showed your setup, you know, so you don't need to write more details, but you can if you want to. So you can say that's equal to integral from 0 to 3 of g of x is x plus sine pi x minus f of x, which is x squared minus 2x dx. And you don't have to simplify anything over here since it's a graphing calculator question. You can do it on your graphing calculator from 0 to 3 of alpha x plus sine shift pi alpha x, close the bracket, minus alpha x squared minus 2 alpha x, and that's our integral. We get our answer to be 3 decimal places, because that's the final answer, to be 5.1366. So it has to round up to 7. So 137. Okay. And that's our final answer for part A. As simple as that. Okay. In part B, what are they asking us? They said the region R is the base of a solid. For the solid, at each x, the cross-section perpendicular to the x-axis is a rectangle with a height x and a base in the region R. Find the volume of a solid. So this is when we learned that the volume of a solid is equal to the integral of the area of its cross-section. Okay, so the volume of a solid is equal to the integral of the area. Okay, what is our cross section here? It's a rectangle. So we have a rectangle. It's given that we have a rectangle with a height of x, and a base, they said, in the region R. So what is the base going to be? So if the height is x, the base in the region R, it means above minus below. Inside the region, above minus below, is just g of x minus f of x. So the base is going to be g of x minus f of x. As simple as that. Okay, that's the base. And the height is x. What is the area of a rectangle? We all know what the area of a rectangle is. It's just base times height. Okay, so we know this. The area of a rectangle is base times height. Okay, find the volume of the solid. How do I find the volume? They said it is perpendicular to the x-axis. So perpendicular to the x-axis means dx. So the volume is going to be equal to integral from 0 to 3 of the area of the cross section. So there's no pi, there's no square. This is not disk method, this is not Washer's method. This is just volume equals the integration of the area of a cross section. And the cross section is a rectangle. And so the area of the rectangle is base times height. So we're just going to do x times g of x minus f of x. Okay, dx. Okay, so we multiplied the height and the base. Okay, base times height. That's the area of the rectangle. And you can substitute the rules they gave us, the function. So you can say v exactly how you're going to type it on the graphing calculator. So v equals integral from 0 to 3 of x times, what is g of x? It's x plus sine pi x, so x plus sine pi x minus f of x minus f of x, and f of x is x squared minus 2x. So minus x squared minus 2x, that's f of x. Okay, dx. Okay, so this is what we're going to type in our graphing calculator right now. So we have integral from 0 to 3 of alpha x times alpha x plus sine pi x. Okay, we make sure to be careful when we're entering the brackets. So you have x plus sine pi x, close this bracket, okay, minus alpha x squared minus 2x. Okay, so we close this bracket and we have one more bracket with, because it starts here and it ends here, right? So we have x outside and we have g of x minus f of x, and that should give us 7.7049. So it rounds up, since it's the final answer, to 3 decimal places. 7.7049, so 5. So that's my final answer for the volume in part B. Okay, so for this rule, since the rules I'm color coding them in dark pink, so we're going to write the rule just like that. Okay, so let's just keep it this way. So that's part B. Okay, let's check part A and B in the scoring guidelines. So question number 2, part A, we got the integral and 5.137 was the final answer. Okay, and in part B, the answer should be 7.705. Okay, and that was part B. Okay, we continue to part C. Write but do not evaluate. So this is a very easy question. Write but do not evaluate an integral expression for the volume of the solid when the region is rotated about the line y equals -2. Let's draw the line y equals -2. Here it is. This is the line y equals -2. Now, if this is my axis of rotation, then clearly the region is far away from the axis of rotation. So I'm going to have a small radius and a large radius. So this is going to be the volume using Washer's method. Okay, so here we're going to use Washer's method. And what's the rule for Washer's method? Volume equals pi integral from a to b, capital R squared minus small r squared dx. Okay. Okay, so that's our rule. So we know that the radii are always perpendicular to the axis of rotation. So we always draw the radius perpendicular to the axis of rotation. So that's my small r, okay? And capital R is also from the axis of rotation, perpendicular until the end of the region. Okay, that's capital R. In order to find capital R and small r, we do above minus below. Okay, and so For capital R, the function above is g of x minus the function below, or the line below. So here the above is g of x. The below is the line y equals -2, right? So g of x minus -2, that's capital R. And small r is f of x is above, and also the line y equals -2 is below. So above is f of x minus below, which is -2. Okay, so capital R is g of x plus 2, and small r is f of x plus 2. We showed our work here. Okay, let's move those down here because we're solving a question. So we found the radii and an expression for the volume without actually calculating. So the volume equals pi integral from 0 to 3. So from 0 to 3 of capital R squared. So g of x plus 2 squared minus small r squared, which is f of x plus 2 squared, okay, just like that, dx. Okay, this is just a bracket, not an absolute value, so as simple as that. That should be your final answer. They only want an integral expression. Okay, so this is part C, pi integral from 0 to 3 of g of x plus 2 squared minus f of x plus 2 squared. So here they tell you that you're allowed to write plus 2 as we did. Okay, and that should be your final answer for part C. Okay, and then part D, finally, it can be shown that g prime of x equals 1 plus pi cosine pi x. So they gave us g prime of x equals 1 plus pi cosine pi x. Find the value of x between 0 and 1, okay, at which the line tangent to the graph of f is parallel to the line tangent to the graph of g. Guys, when we say the line of tangent to the graph of f is parallel to the line tangent to the graph of b, it means the slope of the tangent, so the slope, let's write it down here, the slope of the tangent at f is equal to the slope of the tangent at g, right? So the slopes are equal. When you say we have two parallel lines, it means their slopes are equal. The slope here is just the derivative, right? So f prime of x equals g prime of x. Okay, now f prime of x, where is the function f of x? Here it is. We can derive x squared minus 2x. It's just 2x minus 2. So 2x minus 2 equals, they gave us g prime of x 1 plus pi cosine pi x, and we can draw those two graphs on Desmos and get the point of intersection, right? So we're going to close this calculator and open Desmos. Okay, and we are going to draw the graph of y1, which is 2x minus 2, and draw the graph of y2, which is this expression here. Okay, so I'm not going to rewrite it. This is y2. Okay, so we're going to type it in Desmos. y equals 2x minus 2 and 1 plus pi cosine pi x. Okay, and our value x should be between 0 and 1. So we zoom in. Where is that point of intersection? Between 0 and 1, here it is. Okay, so this is the point of intersection of the two graphs between 0 and 1. It is at x equals, so therefore x equals to 3 decimal places, 0.676. Okay, so 0.6758. We're gonna round it to 0.676, and that's our final answer for part D. Okay, we compare it with the scoring guidelines. Okay, and our answer is correct, 0.676. Okay, and that was free response question number 2.